I've been asked this question about how to solve parking lots in steeply sloping sites. And these are some sample images that have been given. So the site is sloping down this way, and yeah, if you just draw one large flat building pad, this is not really practical. I have just modeled a site here which also has a very steep slope. And if I view the section that I've just cut here, yeah, it's quite steep. So first of all, I'll just use detail line, which I found in annotate, detail line, just to give a rough sketch of what a parking lot can look like. So say that's the back edge of the parking lot. So I'd require, say, an offset of 5 meters where the cars would park, and then 6 meters for driveway, and then another 5 meters, another 5 meters, and 6 meters of driveway, will be another 5 meters. Assuming that I just want to make a large rectangular parking lot where these are cars, and this is driveway. So I'll just call this parking. Parking. Driveway. And yeah, we can assume that the entrance is on this side. So I'll just use these as guidelines. So, of course, what was done in that image was just taking a building pad and drawing a large flat rectangle like that. So if I go to my 3D, in my case, it's gonna be really sunken. Just make an edit here. Section. Say I move this whole topography downwards like that. And I return this to level 0, mark at level 0. And as you can see, our building pad is going to be floating above. Now, different solutions that can be done for such a topography. I'll take note of where the parking starts. Here. Where the parking ends. Here. This is in section view. So let me delete that. So of course, according to different standards, the one I use is our vehicular ramp should have a maximum slope of 1 to 8. Can push it to 1 to 7. Some places even have 1 to 5, but you'll have to really accelerate your car to get up such a ramp. So if we are to have a sloping parking lot like this, then in a parking lot, you would also expect pedestrians, to be walking there. So pedestrian, and that one is a maximum 1 in 12. So one of the things we'll have to test is if we draw a slope from here, will we be able to achieve a slope of 1 in 12, or will it be too steep? So if I start from here to here, what type of slope is that? So different ways of figuring that out. Of course, you could measure and do your calculations from there. Like if this is, you could do that, or you could draw your building pad at this, like this. So when you start from here, you want it to drop by the time it gets to this point, we want it to be about this dimension below. So now we're going to make a sloping building pad, then we see if that is practical. Okay, so we've already drawn these lines here up and down, which are corresponding with that. So I'll draw again a building pad, but this time we make a slope. So there's this function called the slope arrow, where if you draw an arrow like that, you'll be able to set how this building pad will slope. So if I select this line, this arrow, there's a few options here. If I say specify height at tail, then now we'll be able to say what is the height, like how will it raise, which part of this slope will be raised. So of course the tail of an arrow is this and the head of the arrow is here. So we wanted our, at this point, which is here, we want it to slope down, we want it to drop down by this dimension, 3363. So just use a round number. Height offset at head, so at the tail it will remain at 0. The default is the level of this building pad. So at the head, we will make it go negative because it's going downwards, negative 3360. Then say OK. So if this is it. This is how it looks like. So just something we didn't account for is this is not starting exactly at level 0. See, level 0 is right there. Then it's slightly above, so I can just move it up like that. Yeah, so you can see this pad is resting on the slope. But now we have to make sure that it conforms to this. If it's much steeper than that, then you'll have to use different strategy. To measure the slope, you go to annotate spot slope. Then now we click this. Of course, the default units for measuring slope is that, which, okay, so where we learn in our university, we use this type of measurement. So I don't want to do the maths of converting this to these units. Rather, we'll just go to manage units and then slope measurements. We'll say 1:2 ratio. Click this annotation, go to edit type, change the units format to project settings, which is at 1:2 ratio. And so here we're seeing it's 1:9.52. So that is somewhere in between these two. If you are a cruel architect, you would leave it at that. But this is still quite steep for people to walk on, assuming that a vehicle is parked here and by mistake the handbrake is not pulled all the way, vehicles would start rolling down the hill. So making a much gentler slope would be a good solution. But the problem is we have a sloping site. Let me just offset this 5 meters. So if we are to parking, a better solution would be to break this parking lot into different steps. And so each step would have a slightly gentler gradient. So say here, you want us to have a drop. So from here, of course, cars will park here, this will be a driveway, and cars will park here. So let me just use a different line type to show this clearly. Okay. So if we draw this and then a drop of 1.2 meters, and that. So we would have to kind of do that, then now drop by 1.2 meters from here, and start our new slope from this point lower. I'll just copy this line down there. You can see we are still ending up at roughly the same point with a gentler gradient. So that you can do. Now, note that this starts from 500 millimeters above level 0 at this point. So this point here would be like 705 millimeters below level 0. Then the next building pad would start there and would end there. Yeah, so we have split it into two building pads which are also slightly sloped. This difference is what would make up or would make it arrive at the same place. Okay, so let's go to plan view and construct that. So edit boundary. This now we will align to this point because this is the place in between the two parkings. And now remember this arrow was starting at the default, which is 500. If our building pad is at level 0, the tail would be 500 above. Yeah, according to this section, the tail would be 500 above, and then the head would be 705. Minus because it's below. Yeah, so you see now it's at 1 to 13, which is more gentle than this. So this would be it would be a comfortable slope for the parking lot. And then you now just duplicate this. So you could copy this down to that point and just make a few adjustments, like actually moving it up to there. Yeah, so we'll now end up with two slopes that are much gentler. And this building pad now you could move it even slightly higher, so that just to balance out the amount of excavation you would have to do. Yeah, and so that's another solution. And in 3D, you'll have something like this, where there's slight give or take. There's slightly some parts are dug into, some parts are filled up. Yeah, so depending on your situation, you might have to find different ways of mitigating your slope, whether it is one big slope, if that slope is within the comfortable ramp ratios, and that would work. If not, then you'd have to split it. But now, how to deal with this point, because of course you won't expect vehicles to jump in between these regions. Let me just draw the parking points. We'll just draw maybe. So this parking lot is not, what do I say? It has changed itself to be flat, this parking component. That's why it appears to be buried underneath this. But just for the example's sake, we need to create a ramp in between these two levels. So we will edit this and just move that out by 6 meters. And the same thing here. Okay, so of course the ramp would have to start from here and get to this point. So I can do a building pad and that slope arrow. So we are not yet sure how exactly this thing would slope. We'll just leave it there for now. We could move this section here so that we can see how we want our things to slope. So we have this and that. If I switch to wireframe mode, these are just a few things that you just have to work out. Mostly you could work them out by sketching. And since this is a video, I'm kind of trying to do everything on the screen so that you can see what we are doing here. Oh man. So one thing you'd have to do is extend the range of your floor, of your levels, so that they can be seen in section view. I'm just using these to kind of extend the planes of our levels so that now we can see them in section view. Yeah, so now we want our building pad to start from there. This one for the one that's transitioning in between the two. And we would like it to end here. So I'm going to go back to site. So this is what 340 and 1782. So if I edit boundary level 0, this will start at 340 above and end at minus 1782 below. So if you go back to the section, see that going on. Oh wait, it's 340 below. So let's just go back to the site plan view. 340 below level 0. Okay. So we have something like that. So we'll still extend this. So I'll just pick this plane and that plane and trim them out like that. And do the same thing here. And pick this line and that line. And then trim them out like that. Like that, like that. Okay. So our vehicles now will drive in to this more comfortable sloped parking. So they'll stay there. If they want to move to the lower level, they'll come out, go down, and then do that. Yeah. So this is just a scenario of a basic rectangular site. Of course, now depending on your creativity, then you would be able to maybe carve the parking lot slightly so that it follows with the topography, whichever approach you take. But yeah, those are just some solutions for parkings on steeply sloping areas. Thank you very much.